Ooh, recording in progress. Okay, so let me go ahead and do a little bit of minimization over here on my end. There we go. Okay, so chapter 1 is all about vocabulary. I said vocabulary in chapter 1 that I use for the entire semester. So if you want to stay hip to what's happening, you'll spend a fair amount of time with vocabulary. Now, before I go ahead and feed you a bunch of vocabulary words, and I'm going to try to be light about it, because you've got lists, you've got the practice quiz and everything. You've got a lot of different things to work with vocabulary. And we handle vocabulary in Canvas a couple of different ways. One of the things that we do, and I'll be honest, this is less than perfect, but it works okay. On my practice quizzes and my actual real 4 credit quizzes, we have fill in the blanks, and I love fill in the blanks for vocabulary because I can give you a statement. You got to figure out which word needs to go into that statement, or I can ask you to define something and you'll write something down. The problem is, especially with fill in the blank problems in Canvas, is that Canvas is really fussy about its answers, what it's expecting to see. So what usually happens, and I probably should have explained this the other night, students will take a quiz and you can get essentially instantaneous feedback. How many you got right as soon as you turn it in. The problem is that's not the final number. And students don't realize that the first time or two through and they get all freaked out. So some questions on our quizzes, I actually have to go in and physically read and do things and offer up the points. Canvas doesn't grade them automatically. Other questions, and the one that's really important for the topic of vocabulary, the fill in the blank type of questions, students will be essentially correct. And yet you'll still be marked wrong because you didn't phrase your fill in the blank exactly like I did. Truth of the matter is, for the fill in the blank questions, I offer up several different possible answers, trying to get ahead of or get in front of guesses students might make. I can't do that. You guys are way too creative. So invariably what happens is I go in and I grade these kinds of questions by hand. So you really don't know on some of the questions exactly what you got until I've finished my touch. Once I've done that, then you're sure about your grade. But you're going to have fill in the blank questions where you know damn well you got the question right, but you were marked wrong. And that's because either you phrased it just slightly differently, or maybe the spelling was wrong. I don't dig spelling at all. So I'll ask that at least for some of these questions, you be a little bit patient. Students will shoot me email. They'll say, what's going on? And I'll remind you. You'll forget. It's okay. And I'll remind you that at the end of the day, on a lot of the questions, especially fill in the blank vocabulary questions, I really need to make sure your response is correct. I can't trust Canvas to do that for me. So chapter 1 is all about vocabulary. There's really no math in it at all. Oh, there is a little bit of math, reviewing some very basic types of percentage problems, but in general, there's really no math in chapter 1 at all. It is really truly about vocabulary. And I want to start to stress some of these vocabulary words. So these are the kind of things that I hope to discuss in the lecture, along with examples. So I'm going to offer up some very basic definitions. You're going to find them in your summary, chapter summary and technical detail page. But basically your data is just any collection of observations. By the way, the word data, it's plural. Datum is just a single piece of information. We never really use the word datum. It's just kind of there because it's kind of fun to use. But we use the word data all the freaking time. It's any collection of observations. Those collections can be numeric in nature. They can be more qualitative, if you will, things like eye color, political party affiliation, what have you. Now, we are here to take statistics. And really, statistics, it's a science. Interestingly enough, I went to a UCSC just up the road from Hartnell, and our statistician, interestingly enough, did not hang with the math folks at all. The statistician was all the way across campus. I could never figure out why. And I still don't know why. It's still a little odd to me. But at the end of the day, it's really about we organize, we crunch numbers, and we infer. I want to talk for just a moment about this word infer. Infer means to guess. Why do we not say the word guess? Because, well, anyone can guess, but statisticians infer. Infer is really an educated type of guess. And a lot of what we work with this semester is entitled inferential statistics. And a common example that most people will recognize and have some experience with is your political poll. There's an election coming up, and you've got all of these polls appearing on all of these websites and news sites and TV stations and the like, all claiming to know what the vote is going to be or what the breakdown currently is. And if you note, or if you remember, there's always this little plus minus a little smidgen of whatever. This is an example of inference. No one's cast a single vote yet, and they're trying to guess as to what the final outcome of votes might be. And it's not just folly either. It is actually, you can actually get rather close if you follow certain very basic rules that we talk about all semester long. So statistics, it's a way to organize. It's the science of crunching numbers, making inferences. Here's the problem. At the end of the day, we work with a population. Now, a population is just all items, elements, people that share a particular characteristic. For example, you guys are all part, my students are part you're part of the Hartnell student population. What do you need to be a member of our population? You just need to be a student. Stat student? Oh, way more than just stat students, any student. So a population are all the little bits and pieces, things, items, whatever you might want, that share a particular characteristic. And that defining characteristic is what defines the population that you have an interest in studying, at least in the land of statistics. Now, How do we measure a population? Well, if we want to measure a population, there's only a couple of ways to do that. In fact, there's really only one way to do that. We have to take a census. And when you take a census, it's very important here to realize that every, God, I can't spell right now, every population member is counted. Every population member needs to be counted when you take a census. Here in America, it's an important component of our Constitution. The Constitution says every 10 years, you have to count everyone living in the United States. Everyone living in the United States, not just the citizens, but absolutely everyone. Every 10 years. It's a real problem. In fact, quite honestly, it's an impossibility. You really can't count everyone. People live under bridges. People live under the radar. People live off the grid. There's a lot of people, 347 million, I think it was on this latest census, something like that. So what does one do? A census would be perfect, but a census is usually quite unobtainable. How do we measure a sample? We make do, excuse me, how do we measure a population? We use a sample. Now, a sample is just a sub-collection of population elements. We often like the word elements for whatever reason when we refer to populations, but there we go. We use a sample. And you might wonder, well, if you haven't measured anyone, how can you say anything about the large population? And this is where I want to kind of lay out some big picture stuff. What we, come back, there we go. What we like to do is we like to realize that our population is big. Population is big. Within that population, we'll take a sample. The sample will be small compared to the population. The goal with inferential statistics is to be able to take this sample and to infer from the sample so we want to infer from the sample to the population. It's an educated guess, but it is not, it's not an unreasonable thing to try to do. What you have to realize is that any inference or guess, if you will, it's going to be wrong by some degree. If you're expecting to infer or guess and be 100% accurate, you can't do it. That's not what this is about. This is about making an educated guess and getting close in terms of probability. And this is another really big component of statistics, is the notion of probability. What is the chance that when I make this inference, I'm going to be close to reality? That's really the nuts and bolts of where we go this semester. But that is definitely the destination to which we drive the statistical bus. Now, the whole notion of samples in the land of statistics is very, very important. It's really hard for me to overstate the notion of samples because samples are how we measure populations. So a sample should be representative of the population under study. So, in other words, if I was going to study Hartnell College students, I would really want to make sure that when I took a sample of students that I got a representative sample. In other words, the sample itself, in some sense, is proportional to the larger population. And I'm going to go into this in more detail, but this notion of a representative sample means one thing. We want what we call a random sample. And this is really a bit of a gold standard when it comes to statistics. Samples need to be randomly selected. If you pick and choose, then you'll end up with a skewed view of what of what you're trying to study. If I was trying to, let me try to give you another example. If I was trying to study average height of people in our general area, and I went to the Warriors locker room and I measured the Warriors basketball team to get an average height. I don't think that would be average, and I bet you don't think it would be average either. So this whole notion of a representative study is here for us all semester long. I'm going to offer up an example of something that is not a representative study. We have something out there called a voluntary response sample, also referred to as a self-selected sample. And I would bet that most people, when they think of this sort of thing, have actually probably experienced some aspect of this. I think if anyone experiences anything in the land of sampling statistics, they probably experience something like this voluntary or self-selected sample. Let me give you an example. Call-in polls. Anytime someone's asking for you to call in and offer up an opinion on something, this is an example of a self-selected poll. The outcome does not mean anything and cannot be generalized. So we cannot generalize to a larger population. Why? Because it's not going to be a representative sample. Let me give you an example of such a question. Should we change should we change the Second Amendment? That's the right to bear arms. We all have opinions about that, and I'll bet you anything, a lot of us have some really strong opinions about this. So if there is a call-in show that asks you to call in and share your opinion on this, the only way you're going to call in is if you have some strong feelings. Otherwise, you just don't care. You're not going to be invested in calling in and answering that question. And because of that, if it's a question like this that involves all of society, you're only going to get a very skewed view of what's going on in the population if your sample is something like a self-selected sample. It's really interesting the way this goes down. There's a whole science and sub-science, I should say, in statistics that has to do with sampling. So because of that, and this is where I'm going to wrap it up for tonight. Sampling methods matter. And there's a number of different ways to sample. And what I'm going to do tomorrow during my office hours is talk about those sampling methods. But the idea with your sampling method is to develop or build this representative sample. And we have different sampling methods depending on what is being sampled. I don't think you would measure, for example, student success with the same kind of sampling method you would use to make sure that products coming off an assembly line work as advertised. So different sampling requirements depending on what is being sampled. That's really the key here. And what I really need to have students be able to do with this is to really identify different sampling methods when I give you descriptions, or perhaps offer up examples of sampling by different methods. I'm not going to open the sampling methods can of worms tonight. It's much too long of a discussion for our time remaining. So I am going to ask at this point, where'd you guys go? Oh, there you are. I'm sorry. It's like, sometimes you hide up in the corner of my screen. So let me go ahead and switch back to my other camera. Are there any questions? I don't see anything down in chat, but there's an introduction, and this is really kind of what we do. I also like to use this time for worked examples. We're really just starting to get into the whole topic, so there's not much for me to do in the way of worked examples, not much number pushing tonight, but that does come, and it comes pretty quickly. Are there any questions? Okay, I'm going to stop the recording.